Hey everyone, my name's Daniel Wilczak, and today I'm going to show you how a couple college buddies and I built an evolving altitude robot that looks like this and runs off a genetic algorithm. So let's get to it. So I wanted to start off by explaining how the robot works, how it gets its data, and how it operates. So the first thing I want to talk about is how it gets its height above the fan, because when it goes up, it gets its height reading and comes back down. It uses an ultrasonic ranging module, and you can find these on Amazon for about a few dollars, and I've linked them in the bottom. It takes the range using ultrasonic to hit the top of the fan case housing and come back, and that tells you in centimeters how high above. So it transmits that data back to the Arduino. The Arduino handles sending the throttle values to the fan, and it also takes the input from the ultrasonic ranging module. We created a PCB for this because we were doing research and we wanted to have it work every single time the exact same way, where if we did it with wires, and we tried this, it sometimes can loosen a wire or something can pop off, so we wanted to make sure it was good. I added this into links below as a schematic of how this is, and you could print them on JLC PCB. But after that, we have an input for the motor controller, which drives the fan, and it's stored in this small little housing right here. See right there? And it has two different things. It has the power for the battery, or in our case, we use a power supply. And then it has the 3 phases from the motor controller all the way to the fan. And I want to give a shout out to Dylan Ballback because he did the great designing on all of this for the housing and all the ideas on this. And then finally, we have the USB that can either go to a Raspberry Pi or it can go to a laptop. So here we have an example of it running. I decided to give you a full example of it, of how it works, before I start going into code or what we got as our results. But I ran this trial for 4 chromosomes with a generation of size 4, so that it'll run 4 different chromosomes each generation. So as you can see on the right hand side, we have the fitness, which was 635 in millimeters, and then we have our throttle values on the left. These throttle values tell the robot how to move. So how high to go from its starting position to a specific throttle. And the genetic algorithm is basically handling these throttle values, how to put them in a different orientation, mutate the values so that they change. The genetic algorithm handles these chromosomes by moving them, splitting them, making new offsprings, building them together, and then it evaluates them, and that's what the fitness is. So I wanted to go into how the fitness function works on this robot, because I know right off the bat it's not very clear how heights above it will accumulate into a fitness. So I have this other graph that I want to show you guys. So this graph represents heights over time, heights being how far away it is from the ultrasonic ranging module, and then the time it takes, so we recorded in each individual second. The overall fitness is scored by each individual second's score from the desired to the actual. So if we do an absolute value of how far away it is, whether it's above or below, in the example, you could see that the first second was 5 millimeters away, the next one was 18 millimeters away, the following one was 26, and then the next one was 10 over the desired, which was it moving past 6 centimeters. And then the overall score is calculated by summing up all of these differences between the desired and actual. And then we get a total fitness, and then that's what we evaluate the chromosome as. All right, everyone, so stay tuned for part 2 and 3, where I do a full coding overview of the Arduino code and the Python code that gets our robot running. And then in part 3, I'll go over our results that we had for our 3 robots with 30 trials minimum each, one trial being 100 generations with a population size of 15. If you want to see the research now and you want to see the results, I have a link in the description below where I have a paper outlining it. This is a draft. And then I also have the results on my GitHub page with full-on graphs. All right, guys, see ya.